Now, without wasting much time, since we know about the characteristics of our signals, we will base on that to come out with the various types of modulation. And before that, I would like us to talk about why modulation. Or someone may ask, why modulation? One, to transmit signals over a long distance, you need modulation. So to transmit signals over a long distance, you need modulation. For instance, radio waves, which are used for wireless communications, travel best at a higher frequencies, right? However, low frequency signals such as audio and video signals cannot be transmitted over a long distance without significantly attenuation, right? When you are using your voice to just speak to somewhere, or you can't sit at your radio station and talk for your audience to hear without the signal being modulated. In that way, if you don't modulate it, your signal will be, or there will be an attenuation on the way. And therefore, modulation allows us to combine a low frequency signal with a higher frequency carrier signal, which can then be transmitted over a long distance with much less attenuation. That's what you need to take note. So in this one, we can say it helps us to get maybe less attenuation right here. Let's look at the second advantage, why modulation. Modulation also helps us to reduce interference. Let's look at something here. To reduce interference. So basically, different communication systems often operates at different frequencies. And this helps to reduce interference between the systems. However, even systems operating at different frequencies can still interfere with each other if probably they are too close together. So in this case, modulation can help us to reduce this type of interference by spreading the signal out over a wider range of frequencies. So in this way, interference of our signal or the message that we want to convey will be minimized. That's something that we need to take note. And the next one is to allow multiplexing, or let me say multiplexing. When we say multiplexing is a process of transmitting multiple signals. Over a single channel, right? This is done by assigning each signal to a different frequency range, right? So basically, modulation is going to allow us to multiplex these signals by modulating each signal onto a different carrier wave. This is basically why we do modulation. But I would like to show you something here. When you are in your house and then you have a television that uses an antenna. So I know some people may have a very long antenna and some people may have a very short antenna. And that's length of your antenna will depend on the kind of modulated information coming into your system. So in this way, modulation is going to help us to determine the length of our antenna. I hope you remember V equal to F lambda, where V is the velocity of light in air, and then F is the frequency, and then the lambda is the waveform. So in communication system, you can see that lambda equal to V over F, where the lambda is the wavelength, and then you have V over F is your velocity and then the frequency. So we assume that this lambda is the length of your antenna. The antenna. This lambda is the length of your antenna. So if you are transmitting an information with a lower frequency, you know that lambda equal to the velocity of light in air is 3 times 10 to the power 8. And then if you have maybe you are transmitting, let's say 1 kilohertz information, you are going to get lambda equal to 3 times 10 to the power 8 over 1 times 10 to the power 3, which is going to be 3 times 10 to the power 8 minus 3, which is equal to 3 times 10 to the power 5 meters, which is very, very long. And this, it will be very, very hard. It will be very, very hard to get an antenna with a length of 3 times 10 to the power 5 meters. So because of this, when you do modulation, in which the carrier is going to have a very high frequency, let's say 100,000 kilohertz, or let's say 1,000 kilohertz, that's the frequency of your carrier. We can see that the lambda is equal to 3 times 10 to the power 8, which is the constant, over the 1,000 kilohertz. So in this way, it's 3 times 10 to the power 8 minus 6, which is going to give us 3 times 10 to the power 2, which is equal to 300 meters. So in this way, you need an antenna of 300 meters in order to receive the information which is coming on your way. So if a radio station is operating at some point, and then you get an antenna at the back of your house and is not able to get any television station or any radio station that you want, it means that their carrier frequency range is not falling within the antenna length that you are having. So this is once again the power of modulation. The modulation, if you modulate with a higher frequency, carrier frequency, it's help us to determine the length of the antenna that we need. This is one practical application when it comes, or when we talk about modulation. Knowing this, why we do modulation, I would like us to proceed to talk about the various types of modulation, of which we have already discussed already, which is the various characteristics, which is the frequency, the phase, and the amplitude. So as I said earlier on, modulation is the process of changing the amplitude, the phase, and the frequency of a carrier signal with respect to the instantaneous change of the message signal. So if you are changing the amplitude of the carrier signal, we call it AM, which is amplitude modulation. This is AM. When you are changing the frequency of the carrier signal with respect to the instantaneous change of the message signal, we call it FM, which is frequency modulation. And lastly, when you are changing the phase of the carrier signal with respect to the instantaneous change of the message signal, then we call it PM, which is the phase modulation. And you need to take note that all these three modulation types can be classified as analog modulation. As we discussed earlier on, that we have digital communication system and analog communication system. So in this case, the AM, the FM, and then the PM can be classified as analog modulation. This brings us to how you can define AM. When someone asks you what is AM, it's the same as the definition of modulation. You just have to replace everything in terms of AM. So for here, instead of saying that changing the amplitude, the phase, and the frequency of the carrier signal with respect to the instantaneous change in the message signal, what you need to say is that amplitude modulation is the process, or the AM is the process of changing the amplitude of the carrier signal with respect to the instantaneous change in the amplitude of the message signal. So this is how you can define amplitude modulation. The same thing applies to FM. What you need to do is to change everything and then bring in frequency. So for frequency modulation is the process of changing the frequency of a carrier signal with respect to the instantaneous change of the message signal. And the last one is the PM, which is the phase modulation. And the only thing that I need to change is the phase, the process of changing the phase of a carrier signal with respect to the phase of the message signal. So this is how you can define the various types of modulation. And now we understand what communication system is and why modulation is very important over here, and the various types of modulation. I would like to end here for this video, and in my next video we are going to talk about, or we are going to take one after the other, the various types of modulation, which is the AM, the amplitude modulation, the FM, the frequency modulation, and then the PM, the phase modulation. So thank you for watching, and see you in my next video.